Hello, ladies and gentlemen. Welcome to this Innovation Day hosted by Innodisk. This is James from Intel Taiwan. I have been working with Intel for 19 years, and I'm majority doing embedded, phone and tablet, IoT, and AI enabling the market and also the new technology adoptions. Right. Today, I'm using some of the Intel slide to go through what the Intel new strategy is. And also together, there's edge computing introduction and also the offering from Intel on the AI technology. So I'm using this corporate slide and embed this 4004 processor, which created by Intel as the first general CPU for mankind. Right, that's 50 years ago. So let's take a look on how this technology transformed human being in past 40 years and in upcoming 10 to 15 years. All right. So this is just a legal disclaimer. Make sure we're using this material legally. So let's take a look 40 years ago. Right. We start to digitize everything on 1980s. Right. The typical example is the music. Right. You from the tape to CD to MP3. Right. Same as pictures, same as video, same as your paperwork. Right. Then in the 1995, around that time frame, you start to have the dial-up network. You got to have your Ethernet. Then you have your internet. Then we have 3G, 4G, and 5G. And later on in the 2008, you start to mobilize everything. You have PC, you have a cell phone, a smartphone, and then you have a cloud computing, because the mobility device or cell phone may not have enough computing power, so you need a cloud computing. But later, in 10 years, 5 years, you will see more and more connected device. That's how we call 1 billion connected intelligent device. So let's tell you a little bit more on this future trend. In the past 40 years, we've done a lot, right? You look at the technology is changing people's life. And we are going to intercept in the future of 50 years. How Intel going to see in the future and new technology? There are 4 superpowers we are talking about. Right? We are thinking of which may change people's day-to-day life. The first is ubiquitous compute. The second is pervasive connectivity. Then the third is cloud-to-edge infrastructure and AI. And let me explain what is ubiquitous compute, right? Your PC, your notebook is, and your cell phone is compute, right? You're aware of it. And now your car, the car you are driving is also computing, right? And testing how far the adjacent car is. And even the air conditioning is computing, right? Based on the temperature setting, you need to sense the temperature and set the temperature correctly. So that's everywhere is compute. That's how the ubiquitous compute is doing. The second, on the connectivity, think about it. I talk about dial-up network, right? Then you have machine or your person to a server, right? That's kind of a connection there. That's the first generation. Then you have the 3G. You can start to talk about from people to people. You can have your connection there, right? With the data and the video as well. Right? And sooner or later, when 5G get more popular, you will start to see the machine-to-machine kind of communication. Right? That's how we call it pervasive connectivity. Right? Then the third one is cloud-to-edge, right? Infrastructure. You will see in the past 40 years, you've been seeing this transformation many times. The first thing, like 40 years ago, you're using punch card to input to the mainframe. Then next day, you get a result from the printer, right? That's a mainframe time frame. When the PC invent in 1980s, right? You start to do a lot of work, your paperwork, you play a little bit game on your PC. That's so-called decentralized. Then when your mobile device come and the computing power is not enough, so you do a lot of cloud computing on the day. Then you will see this central, decentral, and central, and maybe next time is hybrid. So that we call cloud and edge will compute all the time. And I will talk about edge a little bit more later. And AI is, in the future, it will be a very basic technology for people to adopt. In our next generation, AI is just fundamental. So, but there's one thing we didn't talk about, which is the semiconductor. These four superpower will be enabled by semiconductor, plus the software on top of it. So that's how we Intel vision in the future, in the next 10 years, this four superpower is going to change people's life day to day. So how Intel is going to address these four superpower? The first, we need to have product leadership, right? Why is the product leadership? Intel been good at doing like CPU, like Atom, Core, and Xeon, right? But now we have our internal graphic, and while internal graphic can take it out, become the external graphic. And then we have so-called infrastructure processor. So what is the infrastructure processor? That will improve your network efficiency and also prevent the parking loss. So that means when you transfer data, you will be more efficient and more secure. So that's all we call IPU. So with that, Intel no longer a CPU company, it's an XPU company. That's how we call product leadership. The second, on the open platform, right? In the open platform is now on hardware and also on the software. So take hardware as an example, right? The USB was invented by Intel, one of the Intel employee, right? Think about it, if we take like 1 cent per USB device, it would be a lot of Intel revenue generated today. But we didn't do it. We opened it up, so around the world we can benefit from there. We didn't charge anything. That's how we call open hardware standard, right? That's a very typical example. Another example is we push the Centrino, so that the Wi-Fi become more adoption, right? So that's the hardware. How about software? I give you one example. The 5G, I talk about 5G, right? 5G has 3 dimensions, right? There's a so-called enhanced broadband, there's ultra low latency, and there's a massive deployment on machine to machine. These 3 triangles, are you going to run 3 sets of hardware and run these 3 dimensions on 5G? Or you want to use in 1 set of hardware, depends on workload, depends on the time, and depends on how you want to run it, and just write a software on top of it. So you can configure the same hardware doing the enhanced broadband in the daytime, doing the massive connectivity in the nighttime. So that is how we're going to say this software-defined network is. So it's software and hardware open platform is the strategy we are driving forward, right? The third one is the flexibility on the manufacturing, right? It was IDM 1.0, Intel produced CPU by ourselves, and we not let people to use in that. But now we are open our factory and open our foundry so people can leverage our advanced node. And on the other hand, we also contract out some of our chip to the external foundry. So it become more flexible for our manufacturing strategy, which just able to intercept this 4 superpower and for the future of business. All right, I'm done with this Intel new strategy, and moving to the topic of we want to talk today, edge, right? So by the sentence on the title, right, it's a little bit wordy, but let's see. Let me use in the plain English to explain it. The edge is where the data process, collect, and action, right? So you have data collection, you have data process, then you action on it, right? There are several reasons we are not able to do everything in the cloud, right? On the right-hand side, you see the cloud, right? So you're not able to do it. There's 4 key reasons. It's because of latency issue, because of bandwidth issue, security issue, and the connectivity issue. All of this, we are not able, some of the scenario, we are not able to do it in the cloud. We need to do it on the edge, and maybe need to be smart enough to be on the edge. Let me take one example or 2 examples. One is like 10, 20 years technology. The other one is nowadays technology. They're all about the smart traffic control. The first example is a radar speed radar detector on the highway, right? Are you able to just sense the car they are driving on the freeway, send to cloud and process, make sure it's a speeding or not, then come back and give the machine have a snapshot. Probably not, right? You do it right on the spot. You need to sense the data, process the data, and take action on it, right? That's the 10 to 20 years ago, right? But nowadays, it's more complicated because you have more computing power, you have AI in there, you can sense illegal right turn or left turn, right? So when you want to sense illegal left turn, right turn, you need to have AI model. But are you going to capture all the video back to the cloud and cloud doing the process and come back say, okay, this guy is legal or not legal, or the traffic light is yellow or red or green? Probably not. You want to do it right on the spot. So these two are the example of the edge computing, right? It's similar on the smart traffic control, but due to the latency issue, because the bandwidth issue, we are not able to do it. There are many other reasons, like security, connectivity reason. I can give you more example, but I think we just run into the next topic, which the AI and 5G become the accelerator for edge computing, right? So next, let's talk a little bit about the basic AI, right? AI, to me, people were saying AI is one thing, but actually it's not. To me, there's two parts of AI, right? One is training, one is inferencing. Training is education, right? You need to educate the machine to recognize the things. You need to educate it. So you need to educate the people, just like we educate the kids. This is strawberry, this is the apple, this is bicycle, this is pop them up, right? Once it's been trained, recognize this model, then we apply it. Next time we see a bicycle, in this case, it's a bicycle. We see a bicycle, no matter it's a red color, green color, white color, and which angle it come in, you know it's a bicycle. So these two parts, one is training, education, inferencing is a recognition or the inferencing. So why it related to, why I need to separate it? Because edge computing is more relevant to inferencing. So we are focused on edge and inferencing. And this is how our Intel is going to offer on this AI technology, which is our main topic today, which is OpenVINO. We address this edge inferencing scenario by OpenVINO. The OpenVINO has his history, but let me focus on today how this OpenVINO is going to benefit it and how you're going to run this OpenVINO. The first, OpenVINO will be developed. You can develop AI easily by just your notebook. People were saying, usually think AI, you need a fancy graphic card to do the accelerator. In fact, it's not. You just need your notebook. The reason actually we have that internal graphic you can leverage. Internal graphic, usually you just do it in the so-called display or maybe YouTube, right? That's a very easy job for internal graphic. You can do more fancy. So when you develop your AI software, you can leverage that internal graphic. I usually call it the buy one, get one free. You buy one CPU, get one free GPU for you, but you better utilize when you develop the AI. So that's the benefit of OpenVINO. Let's take a look on how we implement this OpenVINO. There are 3 steps. One is build the model. Second is optimize on your coding, basically hardware. Then you deploy on your edge device. So based on what I say, right, on the training itself, on the AI, right, the train model is open always in the cloud, and TensorFlow, Caffe is the commonly used the train model. And we also have open model too in Intel. That's a train model. So we need to convert this model to put on IA, Intel architecture. Then you can deploy on the so-called edge. So majority of the coding on OpenVINO, which is on optimization, you need to optimize the framework into the CPU or GPU can run in Intel. Then you can deploy in the Linux or Microsoft Windows machine. Okay, so these are the 3-step concept of how you develop OpenVINO. Let's take a look on the benefit of this OpenVINO and how it performs, right, from generation to generation, right. On this we're using the 2018 R5 as a baseline. There are several revisions before that, and that's a lot of improvement. But we take this snapshot, 2018 R5, which is more stable for us to do the benchmark. Then you see 4 times faster on the next release or next 2 release. It's because the hardware changed, right? From first generation Xeon SP process to the second generation, together with the software. But on the next release, 2021.2, you see 25% improvement within this 2 revision. It's just pure software, 25% improvement. And the next, you got the hardware and software altogether, you got 2 times faster. And the next, between this year to last year release, we got 30% of improvement in just the software itself. So we keep improving this OpenVINO software SDK. So what's new in this new release, right? The first thing we realize, people complain, right? The TensorFlow is not so TensorFlow friendly. A lot of people doing the AI workload on the TensorFlow. But so in 2022 release, we have this TensorFlow convention alignment. So people from now on, whoever doing the TensorFlow development, which can easily using OpenVINO to develop their code. The second one, we brought the model support, including this neutral language processing by using dynamic input shape, right? So that means we improve the efficiency of NLP, right? That is the thing, and the detail you can look into the application now. The third one I want to highlight is the auto plugin. The auto plugin, it was in the before release, you need to assign it right on CPU, right on GPU, or right on the other XPU. However, on this revision, you can do it on auto. So the machine or the system will automatically find the most efficient hardware to run on your software. It's very automatic, very efficient, so very developer friendly. So you may not need to care about is running CPU or GPU the most efficient. The next, the more improvement. Last year we got 280 plus pre-trained model in our model 2. This year we got 300. A typical example, we have YOLO V3 on 2019, we have YOLO V4 on 2020, we have YOLO V5 on 2021. So we keep improving our pre-trained model. So after you're done with this build, optimize, and you need to see a deployment. Sometimes you are not able to you don't know what hardware to deploy on, right? You write the notebook you are writing, the code may not be the real machine you are running on the field. So how do you test it? How do you select the hardware? We know your pen, so we know in Intel we do this DevCloud, right? We did this DevCloud is we buy a lot of hardware from our hardware vendor, from Atom to Xeon. So you have an opportunity to try on. You just need to register and put your code in the server machine and assign where this code you want to run on. You want to run on i5, you want to run on i3, or you want to run on Xeon or internal graphic. It can run for you. And the result, based on the result, you can refine which hardware is best fit for you. It could be like i3 together with graphic, or it could be the Xeon alone. It could be like the scenario like that. It solves the problem on the developer because some of the hardware is very expensive, like Xeon server. Some of the hardware is really new, you are not able to get on. But we offer this DevCloud for you to try before you buy. All right, I say a lot, but let's take a look on how this OpenVINO end up with, right? The real application, a real case is happening. On the upright corner, you see that access control, right? It's a face recognition, make sure the people can get in or get out, right? This is fully deployed in Intel Taiwan office. It's the first OpenVINO device in Intel premises, right? That's the right up corner, we see the smart peso kiosk, right? This is the machine with Intel technology inside, with OpenVINO, with RealSense, to measure the dimension of the package, right? And you can put it on scale and weight it, and you enter the mailing address, pay by credit card, then pass over, the package will ship, right? Especially during COVID, you don't need to interact with anybody. You got your package shipped, right? On the right middle column, you will see there's some X-ray result, right? The story is, customer coming to us, they ask, okay, I want to use an i3 together with graphic card. We said, you may try this our i5 with OpenVINO. That's about 3 years ago. And turn out the result is exactly what customer want. Customer is happy, doctor is happy. Why? Because they don't hear the noise fan from their graphic card. And hospital is happy because they don't need to pay extra, like 100 watt or 200 watt for that particular pre-diagnostic machine. So this is a successful case on medical. The bottom one is the same thing. That's a sensor scope, right, to measure your the issue on alarm. But people come in which they want to using the graphic card as well. But we say, okay, maybe you can try i3 with OpenVINO, maybe good enough for you. Yes, indeed, it is good enough. And eventually they can make it as a portable, right? Portable device, and it can meet customers' need. And you think about, I talk about many kind of on the power, right? For example, on the LiPo case, right? You are not able to put 1,000 watts on one LiPo. You probably want to do like 100 or 200 watts on the LiPo. So the power consumption on the edge become very important later on, right? And the last case on the left bottom corner, which is what we have done together with the Innodisk, right? This is the smart retail machine, which can sense your gender, your age, your hairstyle. So the retailer can project the right commercial advertisement for the shopper. So shopper have more intention to buy and generate more revenue for the retailer. This is very many successful stories coming with OpenVINO in Taiwan. All right, that's further than that. We do a lot more. The reason actually is our customer asking us, there's not enough AI developer. There's not enough AI developer for OpenVINO. So last year we do DevCloud, right? We using we have 1 million NT dollar as a total price. So we have 256 team and join and compete and learn each other on the AI development with OpenVINO. That's in Taiwan. And worldwide we have AI Global Festival. So we have submitted 4 to 5 applications last year. We have 2 winners. One is the Taiwan student team to win the Creator Award. The other one is Taiwan Senior High School team to win the Country Award. And doing further, we think the AI will become a fundamental technology for our young generation. So we start with engage on the MOE together with high school. We pick 3 high schools from the northern, middle, and the southern Taiwan. And we train the teacher, and we train also the student to become more AI kind of concept, right? Become our future of AI seed. And this program, AI for Youth, is an Intel worldwide program, which has been adopted by 10, now maybe 20 countries already. And Taiwan will be part of it. We won't be missed. All right, so I think we've done a lot of for this age AI and AI compute. And this year, we definitely have this DevCloud competition again. So the cutoff date is October 11. So there's still like the AI in practice and AI in experience 2 group. So welcome everybody. After you listen to this video, welcome everybody to join and have fun with this competition. Right, there are a lot of information I provide today. I'd like to take 1 minute to summarize what I have to say, right? The first, right, in past 40, 50 years, we using this technology been changing people's life a lot. How about future? We have 4 superpowers we are talking about. One is ubiquitous compute. The second is pervasive connectivity and edge to cloud, cloud to edge infrastructure, and the AI. Right? How Intel is going to address these 4 superpowers? The first is product leadership. The second is the open hardware and software platform. Then the flexibility of manufacturing. So all this is new Intel strategy. And then we talk about the edge, right? Why we need to do edge. There's because the cloud computing is not the latency issue, the bandwidth issue. We are not able to do all the things in the cloud, right? We talk about AI. There's a training and inferencing. Then we talk about OpenVINO, which is very focused on the edge and inferencing part of it. And we have the benefit of the OpenVINO by improving generation by generation. We also have many model tools and benefit of how to write a code on OpenVINO. And also, we have the DevCloud for you to try OpenVINO and deploy on the web before you buy. Right. And then we have the successful story on OpenVINO with edge computing with Taiwan ecosystem. Then we have DevCloud and also AI Festival on the AI competition for people in this community can join. And we also train the future workforce in high school by AI for you. All right. Thanks for your time and listen to this presentation. And hopefully this material is helpful for you. And thanks for your time. See you. Bye.